Welcome back to the Cave of Science, and today we're going to take a look at empirical and molecular formulas. An empirical formula is the simplest whole number ratio of atoms in a compound, and we're going to come back and look at a couple examples of these. The molecular formula is how many atoms of each type are in a molecule. And you may ask, well, can the two be the same? Yes, they can be the same if the formula cannot be simplified. Let's take a look at water, H2O. So we have two atoms of hydrogen and one of oxygen that cannot be simplified any further. So the empirical formula, the simplest whole number ratio, is the same as the molecular formula. Hydrogen peroxide, on the other hand, H2O2, this is the molecular formula, but it can be simplified to HO, which would be the empirical formula. So let's dive in and do a couple of, we'll do an example here, and then later on I'll do another video where actually we'll do some more problems. All right, so let's look here. We got a sample contains 52.14% carbon, 13.13% hydrogen, 34.73% oxygen by mass. Let's assume the percents are grams. Now you may get a problem where they're just going to tell you the number of grams, which is fine also. If you see percentages, assume the percentages are grams here. So essentially we're looking at, we've got 52.14 grams of carbon, 13.13 grams of hydrogen, and 34.73 grams of oxygen. And we can't work with grams, we can only work with moles, or we're going to change all these to moles. So let's look at our first one here, which is carbon. So we have 52.14 grams of carbon, and we know in 1 mole of carbon there are 12.01 grams of carbon. So if we go ahead and do the math here, we find that it comes out to 4.34 moles of carbon. Let's look at our next one. So our next one is hydrogen. So for hydrogen we have 13.13 grams of hydrogen. And we know in 1 mole of hydrogen there are 1.01 grams of hydrogen. So we can go ahead and calculate that out. That ends up being 13.03 moles of hydrogen. So for our last one here, let's take a look at our last one here. We have, we've got oxygen left, excuse me. So we've got 34.73 grams of oxygen. And we know in 1 mole of oxygen, there's 16 grams. So we'll go ahead and do the math here. We come out with 2.17 moles of oxygen. So at this point, we want to determine the lowest whole number ratio. Well, so we're going to do that. We got to find the lowest number here. So it looks like it's going to be 2.17. So if we divide this value by 2.17, we get a value of 1.0. And if we take this value, divide by 2.17, we get a value of 6. And on this one, divided by 2.17, we will get a value of 2. So here's our whole number ratio here. Oh, excuse me, actually that comes out to 2 there. So we've got a 1 to 6 to 2. So our empirical formula would end up being, we've got carbon, we've got 2 carbons, so we'll have C2. Hydrogen we have 6, so H6, and oxygen we have 1. So there's our lowest whole number ratio, and we determined the subscripts for this particular compound here. So that's how you figure out when you start doing empirical formulas. All right, so let's look at if we have an empirical formula. Let's see how we end up finding the molecular formula. So once we got the empirical, which is the lowest whole number ratio, we can also find out the molecular formula. So let's say, for example, what we have here. So our empirical, we know our empirical C2H6O. So we want to find our molecular formula. Well, let's say we're given some information and our molar mass of this compound, the molar mass of the compound is 276.4 grams. So what we want to do from here, we've got the molar mass. Let's go ahead and find the empirical mass. So for the empirical mass, we know we've got 2 carbon. So we know carbon is 12.01 plus we have 6 hydrogens, and we know hydrogen is 1.01, and we have 1 oxygen at 16. So what we can do is add all those together, and we come up with a value of 46.08. And that's our molar mass. This is our molar mass of the empirical. So what we want to do at this point is take our molar mass, which was given of the actual compound, which is 276.4, and we can divide that by 46.08, and we can find what factor we need to multiply everything in the empirical formula by. So if we take our molar mass of 276.4 grams and divide it by our empirical mass of 46.08 grams, we see that comes out to 6. So our empirical mass is 1/6 of the molar mass, or you can think the other way around. The molar mass is 6 times larger than the empirical. So what this means is we would take this value here and multiply all the subscripts of our empirical mass by this value. So C2 now becomes C12. 2 times 6 is 12. Hydrogen, 6 times 6 is 36. And then oxygen is 1, and it'd be 0.6. So this is our molecular mass. And if you go back and double check this, and you want to do the lowest whole number ratio here, you would find that 6 divided by 6 is 1, 36 divided by 6 is 6, and 12 divided by 6 is 2, which would correspond to our empirical formula from up here. So this is a very simple example of finding empirical and molecular formulas. What I'll do on the next video, we'll do some problems, a couple more problems with this, and which will help clear this up if you have any more questions. All right, till next time.